We all think we know honey, right? It's that sweet golden stuff we put in our tea. But what if I told you there's a whole world of complex chemistry happening inside every single drop? Well, let's uncap the jar and see what's really going on in there.
So let's start with the big question. Is honey just a fancy kind of sugar? It's easy to think so, but honestly, that simple answer completely misses the fascinating story of intricate chemistry, natural enzymes, and what are basically unique fingerprints for every honey out there. So here's how we're going to break it all down. First, we'll look beyond the sweetness. Then we'll get into the main building blocks, water and sugar. After that, we'll uncover the hidden treasures that make up just a tiny fraction of honey, learn how to spot quality, and finally, we'll figure out why no two honeys are ever truly the same.
All right, let's dive in. While that amazing sweetness is what honey is famous for, you should really think of it as just the opening act. The real magic, the really cool stuff, lies in all the components you can't immediately taste.
To really understand what makes honey tick, we have to start with the big picture, the main ingredients that make up almost everything inside that jar. So take a look at this. At a glance, honey's recipe seems pretty simple. As you can see, it's mostly water and two main types of sugar. But, and this is the key, it's the precise balance of these simple things that gives honey all of its unique properties.
Okay, first up is water. The moisture content, which is usually right around 17%, is absolutely crucial. See, if there's too much water, the honey could actually ferment and go bad. But with too little, it becomes super thick. This specific range is basically nature's perfect preservative.
Now for the sugar. The main one is fructose. This is what's responsible for that intense sweetness we all know and love. It's also the secret ingredient that helps keep honey liquid for a really long time.
And then you've got glucose. It's not quite as sweet, but it plays a super important role. And here's what's so cool. The ratio of fructose to glucose is what determines whether a honey will crystallize quickly or stay nice and runny for months on end.
But believe it or not, water and sugar are really just the beginning of the story. Now we're going to get into that small remaining percentage. This right here is where honey keeps its biggest secrets, all the things that give it its unique character and even its health benefits.
Just look at this list. It's incredible. We're talking about a whole treasure trove of different compounds. You've got everything from organic acids that give it a little bit of a tang, to minerals pulled straight from the soil, to vital enzymes created by the bees themselves, and even the pigments from flowers that give each honey its unique color.
And here is the most amazing part of all of this. That entire complex cocktail of awesome compounds makes up less than 5% of the total honey. It's a powerful reminder that in nature, sometimes the tiniest ingredients can make the biggest impact.
Okay, so with all this complexity, how can we tell if a honey is fresh and high quality, or if it's been overheated or sitting on a shelf for way too long? Well, the answer lies in two key chemical markers. The first one is an enzyme called diastase. It's naturally in honey, and its activity level basically tells us a story. A higher number, say around 21, generally means you've got fresh, carefully handled honey. It is important to know this varies though. Citrus honeys, for example, naturally have a much lower number, somewhere between 3 and 8. This second marker is something you actually want to see a low number for, hydroxymethylfurfuryl, or HMF for short. This compound only shows up when honey gets heated or stored for a long time. So to put it simply, a low HMF level is a great sign of a fresh, well-cared-for product.
HMF pretty much acts like a thermometer for the honey's history. If you see a high reading, it tells you one of two things. Either it was overheated during processing, which destroys all those delicate enzymes, or it's just been sitting on the shelf for a very, very long time.
So, let's bring this all together. We've looked at the major components, we've uncovered the minor treasures, and we know the quality markers. Now let's see how all this explains why no two jars of honey are ever exactly the same.
This table is a perfect example. A light citrus honey has fewer minerals and colloids, which are just these tiny particles like pollen that give honey its body. But a dark honey? It can have a much richer mineral profile and up to 5 times the amount of colloids. And that leads to a completely different color, flavor, and even texture.
At the end of the day, you can think of every single type of honey as having its own unique chemical fingerprint. That fingerprint is defined by the specific flowers the bees visited and the region they lived in. That's what determines the exact mix of sugars, acids, minerals, and all those other little things.
And this isn't just a fun fact. It has real-world applications. For instance, A honey that comes from a plant source rich in iron could actually provide more benefits for someone with anemia than other types would. It just shows why understanding this stuff really matters.
This incredible natural variation is precisely why we have quality standards. They exist to make sure that a jar labeled, for example, citrus honey, actually matches the chemical fingerprint you'd expect from that source. It's all about ensuring you're getting the authentic, high-quality product you paid for.
So the next time you dip a spoon into a jar of honey, I want you to do more than just taste the sweetness. Think about that unique fingerprint of flowers and enzymes and minerals inside. Think about the journey it took from the hive to your kitchen. What story is that little drop of honey telling you?